Effects of welding on material characteristics. The strength of non-heat-treatable alloys is not affected by the welding heat. However, for cold-worked alloys, the strength at the joint is reduced to that of the annealed state. The loss of strength depends on the heat input, which in turn depends on the process. The heat-treatable alloys also lose their strength at the weld zone. However, the behaviors of aluminium-magnesium-silicon alloys and aluminium-zinc-magnesium alloys should be differentiated. Aluminium-magnesium-silicon alloys can be reversed to their original hardness only by repeating the solution treatment, quenching, and aging steps. This can, however, be seldom applied in practice due to the size of the constructions and the expected distortion. Aluminium-zinc-magnesium alloys, on the other hand, require lower solution treatment temperatures and lower quenching rates for repeating the heat treatment. This behavior is utilized for regaining the strength loss in the heat-affected zone. The welding heat itself is sufficient for solution treatment, and the cooling that follows is sufficiently rapid for the quenching step. The type of the material to be welded, i.e., whether or not it is a heat-treatable alloy, is decisive for the strength attained after welding. Non-heat-treatable cold-worked alloys cannot be reverted to the original cold-work state, e.g., hard, after welding. The joint strength always corresponds to that of the annealed state. A different situation exists for the heat-treatable alloys. In principle, the weld zone, which is in the annealed state after welding, can be reverted to the original age condition by repeating the aging steps of solution treatment, quenching and aging. But there are usually two problems: the large size of the and the distortions. In the aluminium-zinc-magnesium types of alloys, the welding heat suffices for the solution treatment, and the fast cooling is equivalent to a quenching. The joint then ages at room temperature. The loss in strength and hardness in the weld region is typical for aluminium and its alloys. The elongation values increase at first, but then fall slightly at the weld middle, this fall being caused by precipitations. This loss of strength must be considered in designing the welded construction. Calculations should then be based on the reduced allowable stress. The weldable self-hardening aluminium-zinc-magnesium alloys have to be handled differently than the other heat-treatable alloys. The reason for this is the relatively large solution treatment range, from 350 to 500 degrees Celsius, and the slow aging effect at room temperature, natural aging. The solution treatment and quenching occur at much lower levels than for the other heat-treatable alloys. The full strength is regained after a room temperature aging time of 90 days. This effect cannot be attained without additional heat input and quenching for aluminium-magnesium-silicon types of alloys. A slight increase of strength can be attained by artificial aging. Thanks for watching. Remember to like, comment, and subscribe.